Now let's discuss about serializability. What is serializability is, actually you have serial schedules, right? Example, let's say this is one serial schedule T1, T2, T3, all the transactions are executed one by one. When it happens, there will not be any problem. But when the transactions are interleaved, then you might see some of the problems, right? Already we have seen how to avoid them is the question. For that, we have some theoretical notion, that is serializability. So what is serializability is, so if somehow you have, let's say, some concurrent schedule or any schedule, let's say this is some schedule S, this is, let's say, serial schedule. Okay, so serial. Now somehow if you prove that these two schedules are having equivalents, that means both have same resultant database. If you prove that, then definitely this concurrent schedule, if this is concurrent schedule, then we can say that that concurrent schedule is good. Why it is good? Because this and this has same effect on database, and serial schedule generally cannot have concurrency problems because they are going to be executed concurrently, serially, right? So that is a concept. Finally, so in serializability, I am going to prove that some concurrent schedule is equivalent to some serial schedule with respect to the result. But how to do that? For that, there are various mechanisms or various notions or various definitions. So finally, I can say that there are some concurrent schedules which are equivalent to some serial schedule. They are, let's say, in this circle. These are all, let's say, that points. So these are all called serializable schedules. Okay, serializable. And you understand what is serializability, right? Now let me revise it. A schedule is called serializable if it is equivalent to, with respect to result, some serial schedule with respect to the mechanism, otherwise output, otherwise database state. Now this is another circle. These are all schedules. So I can say that your all schedules can be divided into two parts. Some are serializable, some are not serializable. So this point, if you see, this is a schedule but not serializable. This is serial schedule, serializable schedule. Every serial schedule is equivalent to some serial schedule, isn't it obvious? That's why, so serial schedules also comes here. Understand? So that's obvious. So we don't worry about it. But generally what we struggle about is, we take a schedule which is concurrent schedule, and our goal is proving that it is equivalent to some serial schedule. That is the story finally, right? For that, let's begin with one notion. That means, there is some mechanism or some definitions, that is about conflict serializability. So conflict serializability is one concept. Using that, we can prove that two schedules are, equivalent. Otherwise, yes, two schedules are equivalent. Using that concept, I am going to prove that some schedule is equivalent to serial schedule. Okay, now we'll see conflict serializability. I will give rough idea about conflict serializability. Conflict serializability has a definition, so you can see it as a tool. Using that, what I am going to do is, I am going to prove that some schedule is equivalent to serial schedule. Serial schedules are good schedules. From now onwards, let's use more easy words like good and bad. So good schedule, every serial schedule is good schedule because it doesn't have any concurrency effects, right? Otherwise, side effects of concurrency. Now what I do is, I have some concurrent schedule, and using conflict serializability, I prove that this schedule is equivalent to some serial schedule. If I do that, what happens? This and that serial schedule both will have same effect on the database. If serial schedule is good, automatically this concurrent schedule also should be good. That is what my concept. So, but why this conflict serializability? If I how it helps you in converting your schedule, otherwise proving that your schedule is equivalent to some serial schedule, we have to see. For that, you should understand the concept of conflict serializability. First, let's begin with small idea. What is that? Is conflict. So what is conflict? I will tell you first. Example, let's say there are two transactions T1 comma T2. Only focus on a particular operation called read of A, comma write of A. So only focus on this one. Initially, let's say A value is 10. Okay. Now, if I execute this schedule T1 followed by T2, what happens? We'll see. That means read first, after that write. Then T1 is going to read 10, and this write of A is nothing but blind write. I already told you that whenever you do just write without reading, then some value will be blindly updated without seeing the previous value. maybe write of A is modifying this to 20. Now you see one thing, if T1 happens first, that means read of A is done first, then A will be, I mean this T1, T1's read of A will see 10. Now later if you modify it, the 20 will not be seen by T1. Now if I change the order of these two operations, what happens, we'll observe. Example, if T2's write of A is first, after that if you execute T1's read of A, this is called interchanging operations. Whenever you interchange the order of the operations, or if you change the order of the operations, what happens we'll see. So first of all, initially A value was 10, right? So now if you do this one, this will become 20, then you read 20. Here finally T1's read operation is reading 20, here T1's read operation is reading 10. Now my question is, these two transaction orders, otherwise these two schedules, let me say schedules, schedule 1, schedule 2, are they having same result? No, obviously not, because here this is reading 10, this is reading 20. Now I say that whenever you have not only these transactions, any transactions, if they have read operation in one transaction and write operation in another transaction, if their relative order is changed like this, then that two transactions or that two schedules cannot have same effect, they are not equivalent. That's quite obvious, right? That is what the conflict idea, that means that is the main concept of conflict serializability. How we use it we will see first. So let's summarize it. Whenever you have read operation and write operation, their relative order is changed in another schedule, then these two schedules, this first schedule and modified schedule, definitely not same. Now similarly, this is called read-write conflict. That is the meaning of read-write conflict. I am going to use it. Similarly, let me teach you write-read conflict, which is nothing but same thing, but let me similarly teach you. Initially you have write operation here and read operation here, then what happens we'll see. Let's interchange it, read of A, write of A. So it should be read of A here and write of A. In this situation, are they same or not, we'll see. So example, for same database variable A, initially I assume that it is 10, then we are updating it first, then it will become 20, then you are reading it, here you read 20. Now if I execute this schedule, then read of A will read 10, after that you are updating it to 20. So read write conflict, write read conflict, both are same, correct? So in anyhow these two are conflicts. Now we'll see one more conflict, that is write write conflict. So that means when there are two write operations, one transaction has write, another transaction has write, like this, write of A and write of A. You remember one thing, this database item should be same. If this database item is different, though both are write operations, doesn't matter, right? We can interchange them, not a problem. So here T2 write of A, T1 write of A. See now, what happens if initially it is 10, assume that this is making blindly A to 20 and this one 30. Here this one 30, this one 20. See the output. If T1 followed by T2, this schedule is executed, then you see what? Final value 30. Remember it, final value 30. So now case number 2. So initially you have 10 and if this happens, first of all 30, later 20. So you finally you see 20. What I want to say is, when two write operation happens, then if you interchange them, the meaning is changed. That means database state will be different. So these two transaction sets, otherwise these two schedules are not equivalent. Otherwise, whenever write operations are interchanged, you get a different meaning to database. That's why this is called conflict. Finally, whenever you have conflict operations, we should not interchange them. What happens if you interchange? Then you get a different schedule. If your goal is having equivalent schedule, then with your schedule, then the two schedules should have these operations in same order. Example, you have a schedule with this write order, one schedule. Then another schedule, if you say that is equivalent to this schedule, on that this write operation should be same, like T1 followed by T2. But this is here T2 followed by T1 order. So in that way easily we can detect whether two schedules are equivalent or not using these three conflicts: read write, write read. So that is what the concept of conflict serializability. But so far I have not defined what is conflict serializability. I just defined what is conflict. Now I am going to use it. Before that, we first see conflict equivalence. What is conflict equivalence? Let's read the definition of it. Two schedules S comma S dash, okay, are said to be conflict equivalent. We write like this. This is usually in mathematics a symbol for equivalence, and that's why I have written here conflict. That means S is conflict equivalent to S dash if the relative order of conflict operations is same. That means the two schedules should have, relative order. That means they should have same order of conflict operations. That's quite obvious and we understand here already, right? So now we'll see such example. Now we'll see some examples and we check whether the schedules are conflict equivalent or not. So remember one point, whenever two schedules are conflict equivalent, the conflict operations relative order should be same in both of them. We will see now. Example in this schedule, this is conflict operation, correct? Read A to write A, correct? So let's note down. Read to write. Same thing should happen in other schedule also. Then only it is equivalent. So read A, write A, correct? Let's mark it. Here also same. Next. Any other conflict operation? We have read C to write C, correct? In between you can have read B also. Not a problem. Still it is conflict because so it is read operation, it is write operation. So here also read C to write C, there is same order, right? T1 to T2, T1 to T2. Anything else? See, read is not a conflict. Why it is not conflict? I will tell you. Whenever two reads are there, so both are reading some data, right? So whatever the order they read doesn't matter. Example, you see, this is your transaction T1, T2, T1 comma T2. This is schedule S. In that you have read A followed by read A. Second one, let's change the order. T1, T2, and this time T2's read first, after that this one. Why it is not conflict, you will understand. Example, A value is 10. Now do this one, then both will read 10. If you do in this way also, both will read 10, correct? That's why read is not a conflict. Now here only there are two conflict operations, and here also obviously there will be two conflict operations because both are same transaction sets. T1, T2, T1, T2 with same values, right? Same operations. Now only thing is order we should check. Read A to write A, read A to write A, read C to write C, read C to write C. Yes, these two transactions are conflict equivalent. So that means I am not saying that they are good. I am not saying that they are bad, but they have same goodness. That means if left is good, right is good. Left is bad, right is bad. Right? Now we'll come to this one. One more. Is this, S comma S dash, are they equivalent? Using conflict definition, we will see. So first identify conflict operations. So read A to, with respect to read A, is there any conflict operation here? No. With respect to read B, is there any conflict operation? Yes. Read B to write B? Yes. Now, with respect to read of C, you have any conflict operation? No. Read is not a conflict. And some students say, sir, read to write there is a conflict. See, whenever I say conflict, that operation should belongs to two different transactions. These two belongs to same, right? So don't do that. Next, in this one, there is only one conflict operation, read B to write B. One more thing, write to read, sorry. So there are two conflict operations. Let's check here also. Read B, write B, same order. Next, read C, write C. Here write to read, here read to write. Now see, there is a problem, correct? These two are not conflict equivalent. The reason, the order here is T2 to T1, here it is T1 to T2, especially this conflict operation. What is that? Read write conflict. See, read write, otherwise write read, read write. Order is different. That's what I wanted to say. So finally these two schedules are not conflict equivalent, but these two schedules are conflict equivalent. In that way we can check conflict equivalence. But what is the benefit you get, sir? What is our goal? We want to check whether some schedule is good or not, correct? That means it is equivalent to some serial schedule or not. That is what we are going to do now. So somehow what I do is I take some schedule S, and if I prove that my schedule S, which is concurrent, example concurrent schedule, that schedule is equivalent to some serial schedule S dash. So this time I am ensuring that S dash is serial schedule. So what can you conclude from that? Already serial schedule is good and your schedule S is conflict equivalent to that serial schedule, then it should be good, right? So it should not be bad because the effect on the database is same. If S dash has good effect, S will also have same effect. So S and S dash, I mean, so we say that S is conflict serializable. From now onwards, whenever a schedule is conflict serializable, my intention or informal idea is, so the schedule is good. That means that doesn't have any side effect because of this concurrency. That is what the idea. But the problem is, if how there are lot of serial schedules, your schedule might be equivalent to any of them, correct? Then how many times you check it? So it will be time taking, correct? Example, let's say your schedule has 3 transactions, T1, T2, T3. Then how many serial schedules are possible? One interesting question here, that is 3 factorial. If there are n transactions in a schedule, then how many serial schedules possible? N factorial. Sir, why it is 3 factorial for n value 3? Simple, T1, T2, T3, one serial schedule, T1, T3, T2, let me list out. So here I list out T1, T2, T3, one serial schedule, and T1, T3, T2, then T2, T1, T3, T2, T3, T1, T3, T1, T2, and T3, sorry, T3, T2, T1, T3, T1, T2. So easily we can understand that serial schedules are nothing but arranging the transactions in the line. How many transactions we have in each schedule? Let's say n. Then n factorial ways we can arrange n transactions. That's why n factorial serial schedules are possible, but number of concurrent schedules are little bit difficult to calculate. So we'll see that problem also in, while solving the problems. At this moment, understand the concept of conflict serializability. Okay, now we'll see, given a schedule, whether it is conflict serializable or not. Okay, so that is important for us. So what I do is, there are two ways. One is brute force technique. That means take the schedule and write one serial schedule. Example, one serial schedule is all T1, all T2, all T3. That means all the T1 instructions, read A, write A, then T2's instructions, read B, write C, and then T3's instructions, read C. Okay, now we know how to prove whether these two are conflict equivalent or not, correct? So check the conflict operations order. So here, what is the conflict operation? There is only one conflict operation, that is T2 to T3. Now here, what is the conflict operation? Write, read, right? So here it is T2 to T3. Perfect. So there is only one conflict operation and its order is relatively same. Then these two are conflict equivalent, and it is already good schedule. Then this also good schedule. So it is conflict serializable. That is the definition of conflict serializability. Now let me formally write the definition of conflict serializability. A schedule is, whatever I learned, I am writing it. A schedule is called conflict serializable. I write shortcut SES, conflict serializable, if it is equivalent to some serial schedule. That means which equivalence here? Conflict equivalent to, let me write here, conflict equivalent to some serial schedule. Now see, this schedule is conflict equivalent to some serial schedule. That's why this is conflict serializable schedule. So my final goal is to prove that this is good schedule. That is the goal of conflict serializability. So finally at this point you understand it, correct? Now if your fate is bad, this schedule, this serial schedule might not be equal to this schedule with respect to conflict definition. It doesn't mean that this is bad. Why? If these two are not equivalent, it doesn't mean that it cannot be equivalent to other serial schedules, right? Then you have to take at that time one more serial schedule, that is, let's say S2. We have 6 serial schedules with 3 transactions, S1, S2, S3, S4, S5, S6. Now this schedule is not conflict equivalent to S1, try with S2. If your schedule is not conflict equivalent to S2, still it doesn't mean that it is bad. It may be equivalent to this one. Try it again. Again if you fail, try this one. Again if you fail, try this one. Again if you fail, then your schedule is not at all equivalent to any serial schedule with respect to conflict definition. So this schedule is not conflict serializable. So what I want to say is, if your fate is good, like just we got it, I mean just we for us it happened, right? That means for only one serial schedule I tried, but they were equivalent, but that may not be the always case, right? So sometimes what happens is, if you try all the serial schedules, then only you will be able to realize it, correct? That is worst case. So that's why this is not good idea, because checking this conflict equivalence between this schedule and some serial schedule takes, let's say, some 30 seconds. Then if you have 6 schedules, then checking for everything in the worst case takes 3-4 minutes. We should not spend that much time. We have effective ways. So what I do is, rather than doing this brute force technique, we use some knowledge, otherwise common sense. Here what we do is, so finally our goal is what? We have to prove that this is equivalent to some serial schedule, right? Really it is equivalent to some serial schedule, then I can move these operations such a way that, so so that you can form serial schedule. Example, let's say, see, read of A and read of B, read of C. Obviously, this schedule is equivalent to some serial schedule. What is that? Because there is no conflict operation, correct? Then, if I move this read of B to this side, try to understand in a different way. If I move this read of B to this side, there will not be any problem, because these two are not conflict operations. Their order can be anything, right? In that way, by moving it, I proved that this schedule is equivalent to some serial schedule, right? I am not losing the effect. Otherwise, I am not disturbing the conflict operations order. Without that, if you can separate them, then definitely the separation, because of that separation, if you form some serial schedule, I can say that your old schedule and new schedule are equivalent. So because you are forming the new schedule which is serial schedule, so your old schedule also equivalent to serial schedule, and it is good. That is what I am going to do now. So what I do is, I will try to separate them without losing the effect. That means database the effect will be same. Now try to understand it. I'll move read of B to here. Since read of B, read of A not conflict, not problem. Write of C, write of A not conflict. Let's shift it up. Further shift it up. Yes, we can shift it up like this, read of C. Okay. Then I can move read of A down. Now you see T2 entire thing, T1 entire thing followed by T3 entire thing. So without losing the effect, that means by holding, otherwise by not changing the conflict operations, I separated them. Now this is a serial schedule. The old schedule also will have same database effect, correct or not? Because I never change the conflict operations order. Then this also equivalent to your original schedule. Finally, this schedule is good. Your old schedule also will be definitely good because of same conflict serializability definition. This is one more way of understanding conflict serializability. Now we'll see here also one more example. Now we'll see this example. We try to separate these instructions and we'll try to form serial schedule. If we can form, this schedule is conflict serializable. So let's try to move. So read B is, it can't come down, right? So definitely this read B should go up, because we have this write B conflict operation. Now similarly, this write B cannot be moved down because of read B. So now I can say that this write B has been struck up between read of B and read of B. So now I got some order. That means T3 should be first, then T2, then T1. So why, sir? I will try to do T1 first. To do T1 first, then definitely this read of B should be moved, right? But that is not possible. Similarly, so T3 cannot be done after T2. For that, T3 should be moved down. That is not possible because it's conflict operation, right? Their relative order cannot be changed. Now, can I move anything now? So how to move? I can move this one, read B. Let's move that. Okay. Otherwise, you try to move this side, but I can't move. Let's at least go up so that we can go for separation. Like, so now see, T3 is one schedule, complete unit. Now T1. So T1 and T2 should be separated. To do separation, what I can do is, I can't move right of A definitely to up, right? So now the only thing is, I realize that after T3 definitely you should do T1, otherwise first do T1 then T3. There is no problem between T1 and T3, but between T1 and T2 there is a problem. To separate these two, let's say T1 you want to separate like this, T1 followed by T2. To do that, this read of B should be moved up, but this will stop it. So the second opportunity or alternative is T2 to T1. For that, we have to do what? T2 first, after that T1. Then T2 operation should go up. For that, right of A should go up, but this will stop. So finally, it is impossible. The same thing whatever I explained you, that means we can't separate them, can be explained otherwise, can be remembered through a graph called precedence graph. So whatever the concept I explained, that can be drawn as precedence graph. Whatever the conditions we have. Example, you can't move T2 up for sure at any time, correct? Right? So that means in precedence graph, I will keep an edge between T1 and T2. How I keep, I will tell you. So finally, if and all if you want to form a serial schedule, on that serial schedule T2 cannot be first, because you can't move right of here to up. Then if and all if it is equivalent to some serial schedule, on that T1 should be first, then only T2. So that is decided by this conflict. See, read to write conflict, right? So that's why T1 to T2 there is a conflict, then we add an edge from now onwards. In that way we add an edge. So what happens, sir? You will get a cycle. We will see. Now T2 to T1 there is a conflict. So we can't move read B to up. The same thing can be said as T2 should be done first, then only T1, because you can't move T1 up. So T2 to T1, that means T2 to T1. Now see, this condition says that T1 followed by T2. That means in that serial schedule, T1 should be first, then T2. Now in the same serial schedule, T2 should be first, T1 should be next. How it is possible in serial schedules? In serial schedules, T1 to T2 order is possible, otherwise T2 to T1 order is possible, but you can't have these two orders at a time. So that means whenever this precedence graph which you are forming, it has a cycle, then you can't form serial schedule. So that means this schedule cannot be equivalent to any serial schedule. That is the idea. Now let's do it in a mechanical way, that means by rules. So what are the rules to form the precedence graph? I will tell you. First of all, take whenever you feel that something is conflict, draw a graph between, otherwise draw an edge between them. See, T1 to T2 there is a conflict, T1 to T2. For every conflict add an edge, and it should be directed edge. Direction should be like this. If the conflict is read write, then you write T1 to T2. Now, since this conflict is write to read and write belongs to T2, read belongs to T1, then order is T2 to T1, you add like this. And any other conflict we have? Nothing. That's why you form this kind of graph where there is a cycle. Whenever there is a directed cycle, stop it and say your schedule cannot be conflict serializable. That means according to conflict serializability notion, this cannot be good schedule. So according to consciousness of, otherwise according to definition of conflict serializability. So directed cycle. We'll see one more example to understand it clearly. Okay. Now we'll see one more example and we try to directly draw precedence graph. So using that I'm going to solve this problem whether the schedule is conflict serializable or not. So first take three vertices because there are three transactions T1, T2, T3. Take each and every conflict. So read A. With respect to read A, we have any conflicts, we'll see. So go to other transactions and see any read operation or write operation. So read A, but it's not conflict. So we have to only focus on write operations. No write operations on A. So go to next one. See the conflicts with read of B. One is T2 to T3, correct? Yes. Any other conflict with this read of B? Nothing. Now I covered all the conflicts with T2. Then go to T3. With write of B. So with write of B, try to see all the conflicts. So don't go up because already here to here it is covered. When you covered read of B, that's why you don't require to see up. Only see the operations at downside. Now write of B versus anything, no. So it is not having any conflict with anything. Now come to this point, read of C. So we are coming in a systematic way from top to bottom. So read of C versus anything C, conflict. Read of C versus this one, read of C versus write of C. So one is T3 to T1, let me remember it. Second one, read of C to write of C, T3 to T2. So T3 to T2, right? See, we formed a cycle T2 to T3, T3 to T2. Remember it, but let me complete it. So now next T1, write of C to T2, T1 to T2. There is a conflict. T1 to T2. Now after that with read of A, downside no conflict, with right of C downside there is no conflict, correct? So finally we got these many conflicts, and this is a diagram. In this picture, do you have any directed cycle? I can see two directed cycles. One is T1 to T2, T2 to T3, T3 to T1. Second one T2 to T3, T3 to T2. So one cycle is enough, of course, but for completeness, just for curiosity, I drawn all the precedence graph, but that is not generally required. So whenever you get cycle, stop it and say this schedule cannot be equivalent to any serial schedule with respect to conflict serializability notion. And remember one thing, at this moment, it is very easy to check whether a schedule is conflict serializable or not. But remember one thing, conflict serializability is not only serializability. Serializability is different from conflict serializability. How I will tell you. Serializability means if you say that some set schedule is equivalent to, that means some schedule's effect on the database is equal to serial schedule, then we say that schedule is serializable. It means you can have any mechanism, need not be conflict mechanism. So conflict mechanism is one mechanism which is going to say that some schedule is good or bad, right? So how can I understand this serializable and conflict serializable? I will tell you. There are a lot of schedules in the world. They are serializable, S1, S2, S3. But according to conflict notion, some schedules can be caught which are good. So this is S4, S5, S6. Now see, this is another circle. I can say all the schedules. So these are all schedules, concurrent, serial, everything. So these are all the points which are serializable schedules. Serializable. Okay. So what does it mean? They are good. But how do you know? Somehow, let's say I know. I called God and God said these are all serializable schedules. That means they are good. They have same effect as some serial schedule. Now, this is our conflict serializability. That means using conflict serializability definition, using this diagram. So I realize that S4 and S5 and S6, they are good. But it doesn't mean that only these three schedules are good. There might be some schedules which might not be caught, that means which might not get detected by your conflict serializability definition. Sir, still we don't have clarity. Then I give analogy. That analogy is, example, there is one friend of yours and he is let's say coming to your house today, and your father is going to decide whether he is good or bad. But no one can decide whether someone is good or bad, right? It's very complex question. But your father is using some concept, that is, he will ask one question, whether your friend is preparing for gate or not. Assume that in the world, whoever prepares for gate, they are good, and that is what my assumption. So whoever doesn't prepare for gate, they may be good, may not be good. That is what the real idea, general scenario. Okay, so at this moment we assume that means whoever are preparing for gate, they are all hard workers, and they are really good and they are very sincere. And the people who are not sincere, they don't write gate. That is what my assumption. Let's assume that reality is correct. In that scenario, then your father is going to use the trick to decide your friend is good or bad. Example, your friend is Raju, so he wants to meet you. Then, but your father is the barrier. First of all, he has to cross your father, but he will ask lot of questions. Now your father is going to ask question number one, are you preparing for gate? Now see, you cannot lie, okay, you should tell correct answer. Then if you say really you are preparing for gate, then you can escape from him and you can come go inside. That means, so somehow really you are preparing for gate, you are good, then you can escape. That means you can go inside. But the problem with this father is, there is one person, Mr. Ramesh. So he is not preparing for gate, but he is preparing for cat. But though he is preparing for cat, he is good. But your father doesn't have clue whether he is good or bad. Your father has one definition. What is that? Gate students are good, other students are bad. With that, he will filter you and he will send Ramesh back. So now you tell me, the people whoever sent by your father are definitely the people who preparing for gate. They are obviously good, correct, like conflict serializability. If conflict serializability is qualified, that means if your schedule satisfies it, then definitely it is good. But it doesn't mean that whoever qualifies they only good, others are bad, like this. So if someone got rejected by your father, it doesn't mean that they are bad, but your father doesn't have clue about them, right? Conflict serializability. Similarly, schedules, all the people, serial schedules are good people. Conflict serializable schedules are filtered by your father. Your father is having some mechanism, using that he was able to filter some good schedules, but it doesn't mean that they are the only good schedules. But there are some schedules which might be rejected by your father, otherwise which might be rejected by conflict serializability definition. Okay, so that is the idea about this concept. But we have another notion, that is view serializability. So view serializability is having better notion than conflict serializability, or better definition. Using that, we are going to accept more schedules which are good than this one. Like, example, Ramesh, who is preparing for CAT, but somehow your view serializability can detect that Ramesh is also good. Okay, but in real, sir, view serializability covers all the serial schedules. That means, will it be able to decide whether every good schedule is good or not? No. View serializable schedules also can only detect some good schedules, but there are some good schedules might not be detected by view serializability also. Okay,